This video is on wave-particle duality and de Broglie wavelength. If you are interested in learning more about atomic, quantum, and nuclear physics, then please do read the book The Quantum Story, A History in 40 Moments by Jim Baggett. It's a great book. Also watch all the videos in this website. Question number 1. What is the de Broglie hypothesis? What is the equation? The de Broglie hypothesis tells us that particles can behave like waves in terms of diffraction. So the wavelength of a particle is equal to the Planck's constant divided by the momentum of the particle. Question 2. Usain Bolt has a mass of 94 kilograms. He is running with a speed of 10.44 meters per second. What is his wavelength? So the de Broglie wavelength is going to be given by the equation lambda equals h over p, and we know p equals mv. Okay? So this value, I apologize, the exponent didn't show up here, but there should be a very small exponent here. This value is about 10 times smaller than quantum foam, which is really small and immeasurable. Please do go on this website because you'll understand how small this value is. Take out your calculator and fix this exponent because it's not correct. Question 3. An electron which has a mass of 9.11 times 10 to the minus 31 kilograms is traveling with a speed of 10.44 meters per second. What is its wavelength? So it's traveling at the same top speed as Usain Bolt, this electron. We're going to get a wavelength of 6.97 times 10 to the minus 5 meters. So you can see this is 10 to the minus 31, but it just didn't show up. So even though this value is small, it is measurable. Okay, so where in the real world can we see particles such as electrons diffract? In which experiment do electrons diffract? Well, electrons can diffract when they travel through a crystal or graphite. This experiment is called the Davison-Germer experiment. So what do we see here? The bright spot in the middle is maximum. And then you're going to see a dark spot, that's minimum. Then a bright spot, that's maximum. A dim spot, that's minimum. A bright spot, that's maximum. So you could see that the electrons are diffracting. And remember, an electron is a particle that has mass. So we usually thought diffraction was for waves. Now we're saying diffraction is for particles also. Question 5. What is the meaning of wave-particle duality? Well, sometimes waves behave as particles. Particles have mass and volume, and sometimes particles behave as waves. Waves transfer energy. Particles and waves are not as distinct when it comes to big and slow objects as they are with small and fast objects.